We have discussed how to measure system load. Now, let us look at what we do when that load increases. How do we keep the system fast? There are two main ways to grow. Scaling up, also called vertical scaling, means you just buy a much more powerful computer. This is simple, but huge computers are very expensive. Scaling out, or horizontal scaling, means you add many small, cheap computers to share the work. We call this a shared nothing architecture. In reality, most large companies use a clever mixture of both. But remember, there is no magic button you can press to scale a system. The architecture depends entirely on your specific data. For example, let us look at the math. A system designed to handle 100,000 small requests per second is completely different from a system designed to handle just 3 requests per minute. If each of those 3 requests is 2 gigabytes in size, the math might show the total data volume is the same. But the architecture must be completely different. Now, let us move to the final pillar, maintainability. It is a well-known fact that the majority of money spent on software is not spent writing it the first time. The real cost comes later, during maintenance. Maintenance means fixing bugs, restarting broken servers, and adding new features to old code. Engineers hate working on old, messy code, which we call legacy systems. To stop our new code from becoming terrible legacy code, we must follow 3 design principles from the very beginning. As you can see in the diagram, these are operability, simplicity, and evolvability. Let us break these 3 principles down. First is operability. Good software makes life easy for the operations team. The operations team has a hard job. They monitor the health of the system, fix servers when they crash, and install security updates. Good software provides clear dashboards and tools, so the operations team can see exactly what is happening inside the machine without guessing. Second is simplicity. When a brand new engineer joins your company, they should be able to read your code and understand it quickly. If you write code that is overly clever and complicated, it will hide bugs. Removing complexity is the best way to keep software healthy over many years. Finally, the third principle, evolvability. In the real world, business requirements will always change. Your boss will always ask for new features. Evolvability means designing the system so that making changes in the future is safe and easy, not a painful nightmare. The truth is, these 3 principles are connected. If your code has simplicity and good operability, it will naturally have great evolvability. Thank you for watching, and keep building great systems.